Let's consider these two different situations and identify and calculate the energies involved. So we have in part A, a 142 gram lacrosse ball moving at 16 meters per second while 2.5 meters above the ground. So we know the mass, 142 grams. We know it is moving 16 meters per second, and it's at a height of 2.5 meters. Remember, we have three different kinds of energy. Kinetic energy, linear. Okay, if an object is moving linearly. Gravitational potential energy if the object is raised to a height. And then elastic potential energy if something is stretched or compressed. In this situation, we have both a linear kinetic energy and a gravitational potential energy. So then linear kinetic energy equation is a 1/2 mv squared. So this is 1/2. To be able to get joules of energy, we need to convert the grams into kilograms. Remember, 1,000 grams in 1 kilogram. So that's going to move our decimal place 3 places. So this would be 0.142 kilograms. And then multiplied by 16 meters per second, quantity squared. That's going to give us a kinetic energy of 18.18 joules. And again, that is kinetic energy. The lacrosse ball also has a gravitational potential energy, and our equation for that is mgy, where y is that height. So then this is going to be the mass of the object in kilograms, 0.142 kilograms, multiplied by gravity, 9.8 meters per second squared, and then by the height of 2.5 meters. So that's going to give us a gravitational potential energy of 3.48 joules. Those are the only energies that we have associated with the lacrosse ball. Now, in part B, we have a maximum force of 35 newtons applied to stretch a slingshot 41 centimeters. So then we know the maximum force, 35 newtons. And then we also have a distance that we stretch it, 41 centimeters. To be able to calculate, the only thing we have here is an elastic substance. So that's going to be elastic potential energy. Well, we give an object elastic potential energy by doing work to it. So there's several different ways we can think of calculating this amount of energy. Well, this work is equal to the area of the graph. Because the force is not constant, as you stretch something elastic, then you apply more and more force. That relates the graph to a triangle. So then that would be a 1/2 base times height, which would be 1/2 times the maximum force times the distance stretched. We also have the ability to, with the substitution of Hooke's law, 1/2 kx squared. Any of these ways will give you those joules. Based on what we know, I'm going to use the area of the triangle, the 1/2 force times distance. So this is 1/2 times 35 newtons, multiplied by, converting our centimeters to meters, 0.41 meters, is going to give me an elastic potential energy of 7.18 joules. So then this substance has elastic potential energy and 7.18 joules. So identify what you have. Is the object moving? Is it raised to a height? Is something stretched or compressed? And then calculate appropriately. Ponder physics.